Okay, in 4.2, we're actually going to learn how to get an equation for that line that approximates the data. There's a line that goes through those points, or goes through a bunch of them. So we're going to learn how to get an equation for that line. So here's an idea. So let's suppose I have that number of credits and the hours worked per week, and I want to find the best, quote unquote, best line that approximates these data. So one thing I could do is I could just pick a point at the top and the bottom, draw a line between them, use my algebra techniques, find the slope, use the point and the slope to find an equation. Usually we put that little caret symbol or hat, y hat is sometimes I've heard it referred to. It sounds silly, but no, that's the vocabulary I remember. So just using algebra we could do that. But the question we might have is that the best line? Is there a better line that could be even more precise than that? How do we know if that's better or not? So one way to do that is to look at the errors, how far off you are from the points. So we introduced something called this residual. It's the observed value minus the predicted value. So if we look here, let's see if I can highlight. So if we look here at this guy right here, the line, whoops, the line has it up here, so then the residual, so if we look at that line, if we put in 14 into that equation, the line has it about 17.3 would be what the hours worked would be for that student. And so if we subtract those, the residual is negative 7.3. So that actual observation was 7.3 hours per week below what the line thought it should be. So that's the residual. It's a negative in that case because the actual one is below the line. Oops. The way that we could maybe find the best line is to maybe try to minimize those residuals. And kind of like standard deviation, you can't minimize the residuals because some are positive and some are negative. So what we do is we actually try to minimize the least the square of all of those residuals. That's why it's called least squares regression. So let me see if I can open this up, and I'm going to try to see if I think I know how to put YouTube links in there, but now, or at least in the description for the video I can put it. So let me see. Oh, I thought I had this plugin set up. Okay. So I will put a link to this applet as well. And so, can I zoom in a little bit here? Not really. Yeah, it's an applet. This particular applet I can't zoom in. And so what I can do here is I've got these 1, 2, 3, 4, 5 points, and I can change the slope on the line, and I can change the intercept on the line, just move the line up and down, and try to find the least squares. That looks pretty good. Let me show the least squares line. Oh, not bad. I didn't do too bad there. Let's try a different data set. Whoa, that one's not good. Boy, they look all lined up, don't they? Can you see? It's kind of hard to see with all these squares here, but they look pretty lined up. They're definitely negative slope. Something like that. Least squares. Those squares look pretty small though, the sum of those squares. So if we show the line, yeah, I did pretty well there. So this is what the least squares regression is all about. We're not going to be actually calculating the squares and minimizing that. To minimize that, you need some calculus because you're going to find the minimum of this function. We're just going to use technology. That's what it's for. But it's important to understand, like everything else, what that's based on and where that comes from. So let's see if we can find that least squares regression line and then do a prediction for a student that had a 19 on the ACT Math. So I think we actually already have this. See, we have the line already. So when I did that, I can redo this here. So when I do stat regression, simple linear, and I do ACT Math and Compass, and then I just hit compute. It found the equation for the line for us. So here is the equation for the line. It's about double the ACT Math score plus almost 4. So that's the equation for the, if you're looking for mx plus b, it would be like 2x plus 3.6, something like that. So that is predicting the compass algebra score from the ACT math score. I think that we also wanted to do a prediction, so we can actually go back and edit this, and there was prediction. So what is the x value we wanted to predict for an ACT math score of 19? And we're going to hit compute, and so there should be more stuff in here. Kind of a lot of noise here for now. It's kind of hard to understand all of it at this point. Let's see, there it is. So x value, the ACT was our x, so, and it predicted 41.8, so it predicted a compass score of almost 42, and that would just be putting 19 in here. 2 times 19 is 38, plus 4 is about 42, so that's where that about 42 came from. Just plugging that into the line, and you can do it yourself, or you can have StatCrunch do it for you. Okay, so that is the end of 4.2. We have a couple things here. We want to know how to find that least squares regression line. We want to talk about what that slope means, that the slope there is the relation between the x and y, and then the y-intercept is the plus b that you get at the end. That would be if the x is 0, then the y-intercept would tell you what whatever that meaning is. In this case, it doesn't really have any meaning because an ACT of 0 is not possible. I mean, no one. It's really, I don't know. I think I've seen national data, and there are a few students that get 0, so they must just leave it blank. So it doesn't really have any meaning in our context. The y-intercept doesn't have any meaning.